Welcome to video lesson 8.4. Today we're going to look at polynomials. Go ahead and put today's date in the top right hand corner. And our target for today is that I can identify and simplify polynomials by adding and subtracting. So our very first vocabulary word is a polynomial. And polynomials is the sum or difference of monomials. If you think about the words sum and difference, that now means we're allowed to add and subtract. Okay, so since a polynomial is the sum or difference of monomials, an example of it would be like if I have 3x is a monomial. Oops, there we go. And then sum means I'm allowed to add, and I can just add plus 1. Another one would be if I have like 2x squared, that's a monomial, minus 12x, because he's another monomial. So we can now add and subtract. Our next term is terms, the monomials that make up a polynomial. So it's just an individual monomial. Remember, mono means one. Sorry about that. There we go. So monomials. Then our next vocabulary word is like terms. And like terms are the terms with the exact same variables with the exact same exponents. So an example of this would be if I have a 3x and a 2x. They'd be like terms because they both have x's. The same way if I had 5x squared y to the third and 7x squared y to the third, because they have the exact same variables. They both have x's with the exact same power, so 2 and 2. They both have y's, and they both have y's to the third. So those are like terms. Our next vocab is binomial, and binomials have two unlike terms. If you think of bicycle having two wheels, binomials have two unlike terms. So it would be like our 3x plus 1. He has an x, he doesn't. Then lastly, our trinomials have three unlike terms. So like a tricycle has 3 wheels, trinomials have 3 unlike terms. So it'd be like if I had x squared minus 2x plus 1. Okay, and now that we have our vocabulary, let's look at some examples of polynomials. When variables are arranged in alphabetical order, with the highest powers first. Now, the coefficients don't matter as far as descending order goes, just the variable and the highest powers. So our example for this one, and this is our first example, so example 1, we're given 7x squared plus 2x to the fourth minus 11. And we're asked to arrange the terms of each polynomial so that the powers of x are in descending order. So we want to look at we only have one variable, we just have x's. And then we want to arrange them with the highest powers first. So 2x to the fourth is my highest power, x to the fourth, so he comes first. And then my next one is 7x squared, and he's positive, so a plus 7x squared. Now I drop down my minus 11, because he doesn't have a variable, so he comes last. Alright, let's see one more writing in descending order. Example 2, so writing in descending order, it gives us 6x squared plus 5 minus 8x minus 2x to the third. So once again, we only have x's. So we want to put them in order from highest exponent to the lowest. So I have a 2, that's technically a 1, and a 3. So 3 is the highest, so it comes first. Always grab that sign in front because it's a negative 2x to the third. Then after 3 would come my 2, and that's a positive 6x squared, so a plus 6x squared. And then minus 8x because it has a 1 there, so minus 8x to the first. And then lastly, 5 is just a number. He doesn't have a variable or a power, so he comes last. There we go. Now the last thing we're looking at with our polynomials is combining like terms. And combining like terms is only when you can only add or subtract like terms. And like terms, if you remember from our definition, means same variable, same power. That's the only way we can add or subtract them, is if they have the same variable with the same power. And lastly, just a quick reminder, when we're adding and subtracting, the powers do not change. I know we just finished a section on multiplying, raising to a power, and dividing monomials, in which we did work with the powers. When we add and subtract, we do not. We do not change the powers. So here's our example 3. They give us 3x squared minus 4x plus 8 plus 2x minus 7x squared minus 5. So order of operations kicks in. We want to look into the individual parentheses, 3x squared minus 4x plus 8. We check it for like terms. I have an x squared. I don't have any other x squareds. I have just an x. I don't have any other x's in there. So I just drop it down outside of the parentheses. Now, this plus signs don't change anything. So he just drops down, plus. Now look in this second parenthesis for any like terms. I have an x. I don't have any others. I have an x squared. I don't have any others. So it too just drops down as is. So now we check them for like terms. I start out with the 3x squared. And then we say, do I have any other x squareds here in red? I do. I have a minus 7x squared. And then I have my next term is a negative 4x. I check my red ink for any more x's, and I do. I have a plus 2x. And then lastly, I have a plus 8. He's just a number, and I check for any other numbers, and I have a minus 5. So 3x squared minus 7x squared gives us a negative 4x squared. Remember, we do not change the variable's exponents. It stays the same. So 3x squared minus 7x squared is negative 4x squared. Now, always use that sign in front, so that's a negative 4x plus 2x. So that gives us a negative 2x. And then just the numbers. Positive 8 minus 5 is a positive 3. And then we check for any more like terms. He's x squared. He's just an x, so they're different. That's as far as I can go. And our last example is subtracting. So I'm given 3n squared plus 13n to the third plus 5n minus 7n plus 4n to the third. So once again, we check our first parenthesis here for any like terms. He has a power 2, he has a power 3, so they're different, so I just drop them down as is. Now a minus symbol is different from a plus symbol, because a minus actually changes everything. So I distributed in, say that positive 7n is going to become a minus 7n. And that plus 4n to the third becomes a minus 4n to the third. Now that we've changed everybody's sign because of the minus, we look for like terms. So I always like to put them in descending order, so I'm going to look for my highest exponents first. So I have a 13n to the third. And we check for any other n to the thirds. I have a minus 4n to the third. Then my next highest exponent is 3n squared, so he's positive 3n squared. He doesn't have anybody to go with, so my last ones are just my 5n minus 7n, and they're already together, so I just drop them down. Now we combine like terms. So 13n to the third minus 4n to the third is 9n to the third. 3n squared has nobody to go with, so he just drops down. And then 5n minus 7n is negative 2n. And that's as far as we can go because all their powers are different. And that finishes up for polynomials. Thanks. First example has negative 2x squared times 3x squared minus 7x plus 10. So order of operations kicks in. You want to check inside your parentheses. We have a 3x squared and just an x. Can't combine them because their powers aren't the same. He doesn't have anything, so cannot do anything with my parentheses. So next is to say negative 2x squared is right beside of it. That means they're being multiplied, so we have to distribute. So it's going to be negative 2x squared times 3x squared. Then you always want to use the sign in front, so it's a negative, so it's going to be a negative 2x squared times a negative 7x, once again, using that sign in front. And then negative 2x squared times a positive 10. So now we take it one step at a time. We're going to treat this just like it was a monomial. So we're going to multiply our coefficient. So negative 2 times 3 gives us negative 6. And then we have the same base of x. So I'm going to add his powers. 2 plus 2 gives us x to the 4th. Then we move on to our next one. Negative 2x squared times negative 7x. So negative 2 times negative 7 gives us a positive 14. And they both have x's, so this is a 2 plus, this is technically x to the first, so a 1. So 2 plus 1 is 3, so x to the third. Then lastly, negative 2x times 10. So multiply the coefficients and the constants. Negative 2 times 10 is negative 20, and x squared has no way to go with, so it drops down. Now we want to see if it can simplify. So we check for like terms. This is x to the 4th, x to the 3rd, x to the 2nd. So they cannot simplify. And that's as far as we can go. That's our answer. Let's see another example of multiplying upon polynomial by monomial. So example 2 has 3d squared plus 5d minus, there we go, d squared minus 7d plus 12. So this actually has two parts. It has our first parenthesis, which doesn't simplify, and our second parenthesis, which does not simplify. So then we have to distribute again. So 4 times 3d squared. Drop down our plus sign. 4 times 5d. And also 4 is positive, so positive 4. And same way, always have to use that sign in front. So it's a negative d times a positive d squared. So negative d times a negative 7d. And then a negative d times 12. So now we come through and we just multiply one at a time. So 4 times 3d squared. Multiply the number, so 4 times 3 gives us 12. D squared's by himself. Alright, 4 times 5d. 4 times 5 is 20. Our d drops down. Now it's a negative d to the first times d to the second. So I have a 1 and a 2. But also remember that's like a negative 1 times a positive 1, which is going to be a negative. And then 1 plus 2 makes d to the third. Then negative d times negative 7. So once again, we pretend like that's a negative 1. So negative 1 times negative 7 makes a positive 7. And then we have 1 and 2 d's. So it'd be d to the second. Now our last one, negative d times 12, makes a negative 12d. Now we want to check for like terms, and we also want to arrange it in descending order. So what I like to do first is try to find my highest exponent. Who should be first here? So I have a negative d to the third. And then we check, do I have any other d to the thirds? Nope. So then I have a 12d squared, so plus 12d squared. Then I check for any other d squareds, and I have one here, so 7d squared, so plus 7d squared. And then I have a 20d, so plus 20d. And then my last one is a minus 12d. Now, we go through and we combine like terms. So negative d to the third doesn't have anybody to go with, so he just drops down. But I can say positive 12d plus 7d, or sorry, 12d squared plus 7d squared gives us 19d squared. And then 20d minus 12d gives us a positive 8d. Check again for like terms. That's d to the third, d to the second, d to the first, so can't go any farther. So that's our answer. Now, our next example